for like 2 days, and then.
No, it's not nice at all. Like, everybody has a bath, right? So you could always take one, but I could just take baths. That's why swimming is great, because I could shower after some practice, and that's good. But don't like showers after soccer, but
grew up with only baths in our house.
we didn't have a shower.
When you were growing up.
Yeah. So when I went to college, I was so excited because we had no carpeting everywhere. It was all hardwood floors and like, you know, linoleum. And then when I got to college, I had a carpet and a shower. That's amazing. I was so excited. And my roommate, who I love now, she's a good friend. But she was awesome. I'd never lived with my sisters anymore. Too. I was so like too cool for them. I didn't talk to them at all. I was mean. Now I love them and I like spending time with them. Like they're my best friends. But growing up, I treated them horribly. So I was the oldest, and they were 4 and 7 years younger than me. And like they were never cool enough to hang out. And now I love them. I mean, I probably couldn't live with my own sister. She did that much, but it doesn't matter. Yeah. You end up appreciating your parents more when you go to college. Like, because you hear about all these other stories about the other parents or the other kids. Well, my parents are awesome. And you also, I appreciate my siblings more. So it's good to move. All right, sorry. Back to the point. If you have a basis, then each, let's say you know your basis has like 5 vectors in it. Any set of 5 linearly independent vectors in the vector space could make up the basis. Okay? So if the number of vectors in the basis is what it is, regardless of what vectors you're choosing, if they're all linearly independent, they could make up a basis on their own. Okay? So it has no more than n vectors, even if they're made up of different vectors, as long as they're linearly independent. Okay, so since the basis of any vector space is set, it is a set number, regardless of what linearly independent vectors you choose for it, that is a given value for every vector space. And so if you have a vector space that is spanned by a finite set of vectors, then V is called finite dimensional. I don't know what vector space would require an infinite number of vectors to span it as the basis. So while that is called something, in terms of the conceptual need for that, I don't know what that would be. But all the sets we're going to, I suppose if you wanted to find every polynomial would have an infinitely dimensional set because you just have to keep adding more basis vectors to it. Like if you have an nth degree polynomial. Okay, I just gave an example there. All right, but you know, in terms of being able to operate with these bases, they have to be finite dimensional. So the dimension, sorry, let's go back because I feel like we lost track of that. The dimension is, oh, here we go, is the number of vectors in the basis. So if they're asking you to state the dimension of the vector space, that is going to be the number of vectors in the basis. So if we're going to find the dimensions of this subspace, we have to find the basis. Or at least start the process of finding the basis. Yarn?
Never mind. Okay.
So I'm going to write H in terms of the vectors that it could be in the basis, but the vectors that compose the subspace. So V1 could be 3, 0, 1, 0. B2 would be 1, 3, 0, 0. B3 would be -1, -1, 0, 3. And B4 would be 0, 0, 3, 0. So the first vector is the coefficients of A, second vector coefficients of B, and C then D. So if we create a matrix to bring all this together, this is the PB if it's the basis vectors, but we don't know that yet. I'm going to smush these together, and I think I might like.
Wait, shouldn't the ones these really have floor terms?
Why? Oh. Oh, that's one. What did I do? Oh, I'm sorry. I stated that wrong. This is the first one. This is the second one. This is the third one. This is the fourth one.
I was so confused.
I got a little creative there. I totally flipped everything around and transposed it, which I think would work, but I don't know specifically.
Really so
Aren't I doing it again?
What's going on?
Isn't it 3, 1, 1, 0? In which case it's 3, 0, 1, 0.
I'm so good at it. 3, 1, -1.
You did better with it than I did.
Okay, these are the coefficients of A.
3, 0, 1, 0.
Yeah.
Okay. Or 1, 1, 0, 0.
No.
1, 3, 0, 0.
0.
Wait, so are we doing
And
These
then
are like that.
-1, -1?
Yeah, so the way you need to write it are, these are the coefficients of A. These are the coefficients of B.
-1, -1.
These are the coefficients of C.
Should be 4.
And these are the coefficients of D.
Perfect. We made it. Whew. That was complicated.
Wasn't I close?
You were one up.
Oh, okay. I don't know.
I'm really happy we went over it again though, because I was lost.
Yeah, anytime. Okay, so I am going to go ahead and row reduce.
Why are we doing this?
Well, we have to see how many pivot columns we have,
So,
but, go ahead.
like, for this one, because, like, we only have one term with U in it, and all the other terms have, like, an A or a C, like, can't you just know off the bat that, like, it's not possible to add to a different one? Like, that you will have four pivot columns?
Yeah. Or you could just rearrange. So if we rearrange, what I did is I flipped row 2, or column 3 and column 4. That's an elementary column operation. You can interchange any two columns. And then, do you guys see how if I subtract 1/4 of column 1, of column 3 from column 1, that I would have then a pivot column in the first column? Let me write that down. If I do column 1 minus 1/4 column 3, do you see how I get rid of that 1? Okay. So therefore, this is column equivalent to 3, 0, 0, 0.
Why is it limited in column?
I mean, we talked about them, so they were always on the table, but sometimes I would come out, sometimes I would be, but this time it just seemed easier to see that you have 4 pivot columns by doing those column operations. So pivot, pivot, pivot. So we have 4 column vectors, there are 4 pivot columns. So what is the dimension of the subspace? 4, yeah. So this is a 4-dimensional subspace.
What is the ABCD, like, which 4 are in?
Elements of row.
Learn that in algebra 2 honors.
That was a long time ago.
Yeah, yeah, so this symbol means is an element of. And that's the symbol for the real number.
What would you?
What is that symbol called?
It's
It's an element. It means it's an element of the set of real numbers. Yeah, don't leave here without knowing that. That's important. That's Maggie. Okay, so remember the relationship between subspaces and vector spaces, that they can be the space itself, or they can be a number of vectors that are a part of the vector space and satisfy the 3 requirements, A, B, C. A, that the 0 factor can be made or is in there. B, closure under addition. C, closure under scalar multiplication. Well, this states that the dimension of V, so the number of basis vectors in V, has to be greater than or equal to the dimension of each. So, since H is a subset of V, logically, that would follow. Questions on that? So we already talked about this, but if we have a p-dimensional vector space where you have 1 or more basis vectors, that's what that would mean. If you have that many vectors that are in the vector space and they are linearly independent, you can then create a new basis. Because the dimension is always the same. So if you pick that number of linearly independent vectors, it could also be a basis for that vector space. Touched on that a little bit. Okay, so this is something that I've mentioned a couple of times before, but if we are solving the homogeneous equation, and the homogeneous equation has k free variables, that means the spanning set for null A, so the vectors that are in null A, there will be exactly k independent vectors. Okay, meaning the number of free variables determines the dimension of the null set. Yes.
It's like null A. I don't know how to say this so that would make sense. It's like the inverse, except it's not really at all. Like the M and the N, except in terms of like variables and free variables. Like
So the sum of the dimension of the column space and the null space equal the number of columns in the entire PP, or the entire vector space matrix. What's that?
Why does it make sense that you have this same dimension of the basis as you have number of free variables?
Because when you go to solve for the null space, in order to have, okay, so if there are no free variables, the null space is only the trivial solution. So 0 free variables, then the only vector in null space is 0. If you're able to create a null space that has vectors in it, non-zero vectors, you have to have at least one free variable, because you have to be able to write an equation that represents all the vectors that if you multiply them by A, you get 0. And the more free variables, the more ways you can do it, because you're going to define your answers in terms of one weight on one vector if it has only one free variable, and if it has 2 free variables, then you'll have weights on 2 different vectors that will create all the vectors in the null space.
Okay.
So, null A is the number of free variables. The dimension of null A is the number of free variables in the homogeneous equation. And the dimension of column A is the number of pivot columns in A. So we have a total of 1, 2, 3, 4, 5, 6, 7 columns. What is going to be the dimension of column A? In other words, how many vectors would make up column A? Margot? 4. So we have 1, 2, 3, 4. So the dimension of column A is 4. Right. Good job. Now, how many free variables would we then have? Alex? 3. So the dimension of null A is 3. What's going on?
Ray's like, set me for the option, I'll put 0 so the ones that.
Oh, sorry, Ray. Oh, I could feel your heart crushing. Let's fix that. Questions on that? How big would the vectors be in null A?
Ooh, that's a good question.
What space would they go into?
It's like 2 different.
No,
R7.
That's good.
R7. Because it is, null A is made up of flipping these on their sides. That's what null A is. And the number of vectors, the number of free variables that you get, which is also the number of vectors you generate from those free variables, is the number of
So
free
null
variables.
is a 7 by 3 matrix.
Well, no, it's made up of 3 vectors that are 7 by 1.
So,
But if you wanted to write the basis, if you wanted to write PB for null A, which is a change of coordinates, you could smush them together and it would be 7 by 3.
yeah, I don't know.
What's the
Alright, I know it's transfer with that. Small.
Questions?
I know it's the same as the corner though.
Go back to that.
Yeah. Oh, yeah.
Alex,
Alright, we have to have the case tomorrow. Some spaces don't
I
actually.
think you're increasing anxiety amongst the people here.
it's true. Definitely are. Like,
I'm
I
sorry.
thought
Yeah,
I was worried, and I should. And I'm still like, nervous, I still don't.
I'm sorry, you guys are right. There might not be a quiz tomorrow. I wouldn't worry about it.
Also, this is good, I'm not gonna be here on Tuesday, so just do like normal classes.